escape kind of the shell call, so you can execute both commands after that. Maybe do all sorts of things. So they're kind of similar to SQL injections that way. You might have to get creative to escape kind of shell argument.
So this is like an example of Flask app, and this is actually from one of our challenges today. But the main gist of it is that the user provides an input, and that input is directly substituted in the command string using like a Python F string. And like Louis said, we can kind of treat this like in SQL injection. So if we can break out of the quotes, then we can possibly run another command, cat the flag or ls, and get the flag.
The second one we're talking about today is template injection. So it's also known as server-side template injection, SSTI. And it's something similar where a user input actually gets injected into something that the server runs. But in this case, it's for server-side templates. So I guess for people who don't know what they are, templates are, at least web templates, are kind of similar to static HTML files. But instead, there are some components where you can actually inject some dynamic variables and expression. So instead of, you might have, for example, here, that's a static HTML document, but there's some double curly braces where you can insert dynamic variables. So this is actually also from Flask. On the right side, you can see that's the server-sided function call. And you can actually pass in variables in Python and they'll substitute it into the HTML. So every time a user might request the page, that code will run and substitute title into this page. So the typical, there are a lot of templating engines for like JavaScript or Python, but the main one we're going to focus on today is commonly seen in CTF challenges as well as Flask. So usually across all different languages, there are support for the template has syntax support for statements where you just execute code and not get the output, and expressions where it actually prints out the output. So for example, in Flask with Jinja, that's the templating engine. You have curly braces %, and double curly braces actually gives you the output. So these two are some examples. If you do 4 divided by 2, that will give you 2. It actually runs Python code inside. And the second one is specific to Flask Jinja, but if you put in a variable that actually is defined by the Python code, it will just print the variable out. So that's something you can do later. So how can we exploit this? So as I said, most of the examples are in Python Jinja, but they also apply to other languages in different ways. So by default, Flask actually gives templating page. I guess when they substitute it, you get some default variables that you can use. So there's config, which is like the Flask configuration, which is actually just like a dictionary of all the configuration values used by Flask. So that can be useful. Request is actually a request object. So as you see later, these objects can help you exploit the program by escaping into just running any arbitrary Python code. So 2 more examples here. If you do config.items, it actually returns all the Flask config items, so you might get secret keys inside. And if you do request.application.globals, this is very specific, but basically the idea is you can access the attributes of any sort of variable and get access to even more Python functions and variables that you can use to arbitrarily execute code. So this is a Jinja example with Flask. This application is very short, but as you can see here, there's a short template that doesn't have to be HTML. That actually substitutes some code, some templated code into the string. And it takes it from the request, so that's something that we can control. And for the next slide, you can send in some Python templating code as I showed this down. In this case, we're trying to print out the config items, and if you test it out locally, we're just it actually prints out this thing. So as you can see, it's actually almost like you're printing out config items in your home terminal. And you can see that Flask actually stores secret keys and it's a config variable. So if there's an exploit, if you can exploit a web application like this to run in Flask, you can actually see that. And if you go even further with what I explained about with the requests, and so you can actually arbitrarily execute shell commands. So another example is the one I was telling you about. This is just a photo because there's no point going into this. But a lot of the variables inside within this class or dictionary is usable, and if you access them in the right way, you can just arbitrarily run a shell command, which is not a good thing. A good thing for us.
So now we're going to pivot to SSRF, which is also known as server-side request-forwarding. So the most basic form of SSRF is where you query a server with an arbitrary URL, and the server will request that URL and return the contents to you. And today, this is a typical network diagram of an app where there's a variant of it. So we have example.com, which is what a user would see. And in the backend of example.com, it has a database and it also has an API that it requests. So to us, the users, the database and the API aren't available at all because they're in a private network. But if this application was vulnerable to SSRF, then you would be able to access database and API directly. So common places where SSRF exists, if there is an HTML to PDF or an image renderer, you can have arbitrary HTML either through something like an iframe or a script text, and that would return the content of the internal service. Link preview generators. So if you notice, like if you paste a link in Discord or Twitter, sometimes they'll render like a picture of what the URL will actually be. And if it is vulnerable, then you can just pass in some internal service and you'll get a response from that. Another thing is webhooks. So if an application allows you to put a webhook URL that it would send a webhook to, then you could possibly make it send data to some internal service. And generally, anywhere you see external resource imports, so let's say like something like a Google Drive, Google Slide, if you can import an image from a URL, maybe you could import something like secret value or secret URL instead. And another thing, there's the referrer headers. So if you click a link from another site, your browser will send a header called the referrer header with the value of the site that you came from, and some analytics stacks will take that header value and actually visit it for some analytic purposes, and you might be able to get SSRF that way. So what happens if you actually do get SSRF? You'd be able to internally working it. So if there are any other services running on people's machine, maybe like a database or another API, you'd be able to access sensitive information there. Or you could also pivot to the network itself. So something like the network diagram I had earlier, you'd be able to go into the database or back by the APIs. And a fun one is if you have your application running on the cloud, All the major cloud providers, like AWS, Google Cloud, Azure, they have something called cloud instance metadata services. And they're meant for if your app wants to know some information about where it's hosted itself. So things like the machine name, the IP. But there's also a feature where you can query that instance metadata service and get things like AWS secret keys or Google Cloud Service Account credentials. And if you have those, then you'd be able to go into other cloud services and see what information. And then here are the two links. Those are the actual URLs for the instance metadata services. The 169.254 IP is a IP that's not in the public space. So if you visit that on your laptop, you wouldn't be able to look at that. And it would only work through like the actual AWS instance. So this is a case where SSRF would be the only way, or one of the only ways to access that data. And then Google Cloud has the same thing. Instead of the 169 IP, they like to use the metadata.google internal domain, but the IP also works on Google Cloud. So here's a simple example, also from one of our challenges today. It's just fetching a URL that's provided in the URL parameter and using the Python request module to directly get that and then return the text. So a typical use case for this might be like if you're submitting an image from another external site and you need to get that image to store locally, then you would pass the URL to the image. But if we want to export this with SSRF, then we could actually pass in the IP or the domain of the internet service. So, for example, that would be our request, the HTTP to which would be like the API, and then we can do /that. And normally we wouldn't be able to do that because it is. And another thing is blind SSRF. So that's when you're able to make the server do the query for you, but the server doesn't respond with the actual contents. So depending on that, depending on these conditions, like the response code, response time, and error messages, you might be able to do something more. So for example, if the application returns with like SP2023, which represents success, then we might know that the URL was actually visited. Or if there's like an HTTP500 error, then that might represent a URL or service that doesn't exist. And for response time, if it takes a while to load, that might represent something that doesn't actually exist. While if it takes like, if it responds instantly, then that could possibly be service. And if there are any error messages, that could tell you that you have suspect. So next meetings, tomorrow is SIGPwny, and we will be playing that virtually. And this Sunday, Rohit is talking about a macOS privilege escalation bug, and he had a big value for that, so it's interesting. Next Thursday, will be 23, and we'll be talking about ROP. And then the day after that, we'll be SIGPwny. And we have some challenges on CTF.SIGPwny.com. CalState as a service is command injection. Name machine is network injection, and then SSRF into the network. And here's the new flag.
Dan, Thank you. You guys want to do like a Q&A for a couple of minutes?
Sure. Does anyone have any questions?
And like repeat the question.
Yeah, so the question was if I could explain the AWS metadata service again. So there's an endpoint that all the cloud services run at that IP. Most of them are at the same IP. So if you request that, like if you have a EC2 instance and you curl that IP, that'll return some metadata about the current instance. So usually that data is where you want to have like monitoring or just like for your own use. But we can attack that by using, sometimes they have like service accounts or AWS keys attached to that instance. And we can use those keys to try to access another service, like AWS S3 buckets or someone.
In your example for SSRF, you showed IP, the 10. You got the exploitation example. Right? So when I'm trying my exploit for the SSRF challenges, should I use that IP or is there another IP I should try?
So the question was, I use this 10.0.02 IP, but in actual challenges, should I be using that IP? If you want to go back to the network diagram slide, that's actually where I got the IP from. So if the challenges, in the challenges you notice like any other services are running, or if there's a service running on localhost, then we would want to use that instead. So I think for the first few SSR challenges, we want to use either like localhost or 127.0.1.
So what's your creation of you could do and
Like why does this vulnerability exist?
so this is like the
Yeah. It's like, does Jinja ever sanitize the input? Like, why is this vulnerability a thing?
Yeah, so if you go back, here. So the reason why the vulnerability is a thing is because in this case, this application is actually not vulnerable because Jinja's intended way to pass in like variables is through like the render template function, or I think if you have way more variables, you can just put it pass in the dictionary. In this case, on the server side, it substitutes. There's no template that you can inject because if you inject it, let's say you put this curly double curly braces over there, I'll actually just put that as a string here because it'll substitute that for this. So you're not actually injecting anything. And the reason why the vulnerability exists is that if you see on this next slide, here, I completely bypass passing the variable to the function. I straight up just do the Python like string formatting and put it in there. So it's the difference between letting Python substitute, I guess, the user input, or letting Jinja substitute the user input. And because if you substitute the user input using Jinja, it won't execute. It's going to substitute it as a string, and it knows it's a string, and it shouldn't trust it. But in this case, it doesn't know if it's a string or not. All right. It's kind of like, let's see. For example, when you do SQL injection, one of the ways to protect yourself against SQL injections is to, I think it's called prepare statements. And basically, it doesn't matter what it is. It'll substitute the string directly as a string. It's like saying, if I put code that can be executed as Python into a string, Python's gonna know it's not like code to be executed. It's actually just a string. So if you substitute a template parameter to the previous slide, it'll just put the exact string that you pass it into the template. But in this case, Jinja's gonna think the string you put in here is the template itself. So it's the difference between putting a string inside a template versus putting a string inside another string and using that string as a template.
So maybe it's like the string substitution is twice.
Yeah, so you want to make sure that you let Jinja handle the template substitution. Never put your own code, put user input into the template. Any more questions?
We do like a demo of like SSRF1 or something.
Yeah. Do you want to do that now, or do you want to like announce that we can help people raise their hand?
Yeah.
right now?
Yeah, we can just announce help people. Sure. We can help people and then we can say demo in a few minutes.
Yeah, so
You guys can get started with the challenges, and if you guys need any help, there'll be people around, just raise your hand and we'll go over it, but, Carla can help you. Yeah, so these are again, are the challenges that, we're getting through our presentation today.
And also for the SSRF slide, can we just like make it slightly more clear?
About the localhost.
Like what the substituted string looks like at each step. I think it's like sort of hard to visualize, like maybe in like red text, what the substitute version is.
Okay, then what is for the template thing? Just in this example, we're passing in the double curly brace 1+1. And then that's what my template would look like, right? And now since there's the double curly braces, Jinja thinks that it should substitute this text with like a template thing. And this is the vulnerability, right? The vulnerability is that we're basically like taking a user input and using it as part of the template. So now like our template is being controlled by the user in a way. So now when it's rendered, we can get it to execute Python code, right? Anything in our curly braces is now a Python like expression that can be executed.
Right. So we're going to demo one of the SSRF challenges now. A lot of you have already solved SSRF1. So I'll show SSRF2. We just I guess switch.
Is this
I'm back in normal. Okay, so our goal is to somehow load /flag.php. I'm gonna give me more. All right. So our goal is to somehow load /flag.php from the following website. So if we just go to it, we can see we got this picture gallery thing here, and if we click get image, it like loads a site and displays it displays the image. But so
it only works with JPEG.
yeah, apparently it only works with JPEG. So now if we try to like let's say we want /flag.php, so we'll try to like navigate to that first, since we should just try it just in case if it does work, right? We get this error, it says no touching my flag, right? So clearly this file exists, but the server is preventing us from accessing it. But using SSRF, we can make a request for this flag.php file by pretending we are the server by using a localhost request, right? So for now, let me just kind of demo this a little bit more. If we can put in any arbitrary URL here, so I'll put in like google.com, for example. And you can see it does load like Google here, right? although it's a little bit broken. But if we now like, let's change the URL so it's localhost instead. And you can also use the IP address 127.0.0.1, so I'll put that there instead. Put an extra dot. So this is essentially localhost. So if we request this, it's actually just the site again because we're requesting the index page of the website. So now if we put in /flag.php, we can get our flag. So this is if in case you guys didn't really catch how that worked, essentially we sent a request from the server itself to get the file, and then the server then responded with the response of their request to itself back to us. So if you want to think about it, it's like the server is sending us the file on behalf of itself, right? And so in the case of like, if this is running on an EWS instance, like an Amazon Web Services, then you could put in like that earlier 169 IP, and you could extract metadata about the Amazon Web Service from the server itself, because the server is acting on behalf of you. So because of that, the server can access things that you can't access normally. So one of those things is localhost services, or you can scan, or you can access services on the internal network, which is what Daniel was explaining with the external website requesting stuff from an internal API. Yeah, so the 127.0.0.1 IP address, this is localhost. If you ever want to view some like a service that is running on your computer, you would use that IP. It's like it's what we call a loopback address. So if you it's essentially your computer's IP. Not necessarily in the sense that anyone else can access it, because if they access 127.0.0.1 on their device, it would be, their device. It's like it circles around back to your device. So we're essentially accessing the server's own web service from itself, if that makes sense.
You want to look at the source code too?
Yeah, I can also show the source code just down here. So as you can see, it just you specify an HTTP URL, and it'll get the contents of that file, which is supposed to be a JPEG, but it just shows it as text for some reason.
Well, it needs to end in .jpeg, which is fine.
It just needs to end in Dutch. Yeah.
Basically, target request.
Yes.
So this.
So in this case, the file wasn't a JPEG image, so it just displayed the contents of the
But that
file.
was in the end.
Yeah.
It's still